So all I'm going to do, if I have a common denominator, right, when you add or subtract, that denominator just remains the same. So don't change that. If you have a common denominator, you're literally just going to keep that the same. What would you put on the top of the fraction? 9, okay? Now, can I just, in any way, I've got 9 over 3a. Is that as simplified as I can go? What else could I do there? You could divide the 3. So everything's a product here, right? I've got just a 9 on the top, 3 times a is a product on the bottom. 9 divided by 3, totally legal. This is 3. It would stay on the top because you get the bigger number on the top, and the a would go on the bottom. All right, and I know you guys can do restrictions. We're not going to worry about restrictions today. We're just going to solve these problems. Okay, now the next one, super tricky. So when you work on this, you're going to keep your denominator the same. So common denominator, when you add or subtract, that should not change. You're only working with the numerator. If you're subtracting, like I am here, and this has a couple terms, you have to subtract all the terms that follow that. So on the top of that, you'd have 5x minus 1. It'd be minus a negative. So it would actually turn into plus 7x, and then minus that 8, so it would be minus 8. If it's a positive there, negative times a positive will become negative, and then combine your like terms. So just be real careful with that, especially if you have subtraction, that you distribute the subtraction symbol. It's like distributing a little -1. So if I combine my like terms there, what do we have? Let's see, 7 and 5 is 12, right? -1, -8 is -9. You can factor the top of that because both of those guys are divisible by 3. So if you want to just try and check, if I divide both of those by 3, oh yeah, actually on this one, this would be 4x minus 3. So if now we have a product, this kind of turns into the questions we were doing yesterday. Sometimes you might be able to cancel something, sometimes not. This particular problem, if I take that greatest common factor of 3 out in front of the top of that fraction, you can now have a product on the top. Here, this can actually cancel that whole thing out. So my answer to this question actually just simplifies to be 3. It depends on the problem. That doesn't always happen, but if you can, after you do the subtraction or addition, if you can factor something, it's possible something else might cancel out. All right. Now, just going to leave the bottom of this in factored form, but I'm going to subtract here. So when I subtract the top of the fraction, we're going to have x squared plus 7x. It's going to be minus x squared, and then you're going to have minus a negative 35, so it's actually plus 35. The x squareds, one's positive and one's negative, so those will cancel each other out. So on the top, I just did the top of the fraction, I have 7x plus 35. Now, the common denominator, that was already there for me, so we'd have x plus 5, x minus 4 on the bottom. Can I factor the top of that in any way, just to check to see if anything else cancels out? Do 7x and 35 have anything in common? 7. Okay, what would you have? If you took a 7 out, what would you have left? Perfect. All right, now, we got product on the top, right? If I do that, and then we got x plus 5, x minus 4. So actually in this question, these guys are going to cancel each other out. So that's all gone, and we'd have a 7 left on the top, x minus 4 on the bottom. All right, and then I have one more here. Again, if I tried to do more subtraction, because if it's addition, it's not quite as tricky. I have a common denominator. It's x plus 3, so I'm just going to operate on the top. If you're subtracting, just be careful that you actually subtract any term up there, bless you, on that fraction. So this would become minus 2x, but then I have minus a negative, so it's going to become plus 21. So just the top of that fraction, you got x squared plus 10x plus 21. And that's over x plus 3. That was the common denominator. Now, before I write that as my answer, can I factor the top, the x squared plus 10x plus 21? Could you think of two numbers you'd multiply, they'd give you 21, add you, they'd get you 10? Yeah. Yes. Okay. So factored form at the top of that, x plus 3, x plus 7, and that happens to match up with our denominator. So because the x plus 3's match, these cancel, and you don't even have a fraction anymore, the answer would just be x plus 7. Is anybody having a question? Okay, now we're going to practice with just plain numbers for a second that don't have a common denominator. So when you're adding or subtracting fractions, the denominator has to be the same before you can actually add or subtract. So I just want to see if you guys remember how to do this. So neither of these little examples I have here with numbers have a common denominator. So if I have 1/2 plus 1/3, can anybody just raise your hand and tell me, like, what would you do to create a common denominator? There you go. Okay. We have to do this with multiplication. You can't just like add something or subtract something into a fraction. When I'm multiplying there, in both cases, we're really multiplying by 1, right? 3 over 3 is 1, 2 over 2 is 1. So we're not changing the value of the expression. That's important. So when you do that, this is kind of like unsimplifying a fraction, basically. So this would be 3 over 6, right? That's a half. I'm just unsimplifying it so I can add these together. All right, this guy, 2 and 2, we had 2, 6. The goal there, the common denominator. If you have the same denominator, then you can actually add them together. So we just go ahead and go across the top. 2 plus 3 would be 5. What would I do in the 4/5 minus 3/10 to be able to subtract those two? Yes. Okay. You don't always have to multiply both of them. Like if you, here I had 2. You're not multiplying 2 by anything to get 3. But here, if you can multiply 5 by something to get 10, you might only have to multiply one of the fractions. And that happens in some of these problems we're going to work on here in a second with variables. So this would be 8/10. That's the same thing as 4/5 minus 3/10. And then you keep that denominator the same. It's in tenths. Subtract across the top there, this would just end up being 5. And then if you can, you are allowed to reduce these after you have subtracted them or added them together. So you can reduce, so 5 over 10 would be a half. Is anybody having a question? Because this is going to get weirder with the variables. Okay, now what we call the least common multiple, which I really like to call the least common denominator, because that's what it really is when you do these problems. So in the 2 questions above, the least common multiple up here between 2 and 3, the least common multiple was 6, right? And between 5 and 10, the least common multiple was 10. You're trying to find a number that both of those go into. When you're working with variables, which is what we're going to do underneath, you have to make the smallest expression possible that all of the variables would divide into. All right, so least common multiple, it's going to be your least common denominator. It's going to be an expression. Here, I guess I should write that. Expression, in our cases that we're going to work with, that each denominator divides into. All right, now these can be weird until you get used to it, but they're not terrible. So if I've got variables, this first one's not going to be bad. So I have 10x and 3x squared. So if you've got numbers like I do here, just got a little product. We don't have it like little sets of parentheses or anything. So what is the smallest number that you can think of that both 10 and 3 would divide into? Yeah, I think it's just 30. Okay, now, the least common multiple has to be for variables, the biggest variable that you have. Okay, so like this is a 10x and this is a 3x squared. So my least common multiple that both of those would divide into would have to be the highest power on your variable. So it's got to be the x squared. So that would be a least common denominator between those two terms. All right, both numbers have to divide in it and both variables have to divide into it. So when you're working with the number, just like you would do with regular numbers, when you're working with a variable like that, it's got to be the biggest exponent. Okay, now, if you're working with this situation where we're going to actually factor this, just real quick. All right, this first one, little difference of squares, I'm going to factor these. You want to put it in factored form to find your least common multiple. All right, so I just factored that. Just difference of squares, x minus 4, x plus 4. The other one, can you guys think of two numbers multiply to get you 32, add to get you 12? 8 and 4. Okay, now here's how this works. The least common multiple between both of these, you have to get something that both of those would divide into. So here's the deal. They both already have an x plus 4. So that's going to be part of your answer. All right. Now, this one has an x minus 4. So if we were creating a common denominator, this one would need that. But I'm just going to write the least common multiple here underneath. And this one has an x plus 8, but this one doesn't. So as part of my least common multiple, I would need that x plus 8. So the least common multiple between those two would be all three. We're not multiplying this out or anything like that, but you would need to represent every little set of parentheses in your denominator. You don't have to write them twice. And like right here, I don't have to write x plus 4 twice. I just have to write it once. But that would be the least common multiple between those two quadratics there. Okay, now this one always messes people up when you actually do a problem. I literally have x, and then if you want to think about that, x minus 7 being in parentheses. When you see this in an actual problem, the thing that trips people up, you can't subtract something into a fraction, which is what we're going to work with on the back. So if these are the two things, you can't just put a minus 7. You're going to have to list both of those. It would be x times x minus 7. Whenever you do a least common multiple, it's going to be a product when you have your expression. But in that case, it's going to be the x and separately the x minus 7. That would be like the lowest common denominator if we had that in the bottom of a fraction. Okay, so here's what we're going to do on the back, because we're going to create these and then add these guys together. Okay. Maybe we're going to do this. I can't get this on the screen. All right, so I'm going to add or subtract. All right, so these denominators don't match, so we got to make them match. What would I need to multiply the first fraction by? Anybody know? Do I need a 3? I don't think we need a number. I need a variable, though. Grace, what do you think? Yes, ma'am. Okay, this one has 8 to the third. So this needs 2 more a's. Okay, now this one has b to the third. What would you have to multiply this question, or this part of the problem by? The second term. B squared. It's the same thing. Okay, now, whatever you do to the bottom, you have to do exactly the same thing to the top. We're just multiplying here. Now, the top of this fraction then would become 8a squared, and your common denominator here is going to be a cubed b cubed. The top of the second fraction is going to become 10b squared. The denominator should be the same. That's the least common multiple between those two. It would be a cubed b cubed to make them match up. All right, once you got that, you're just going to simplify. All right, now, what is this? We'd have, you can't actually combine anything across the top here because those are two different variables. They're not like terms. And, excuse me, I don't have any perfect squares or anything like that. I can't factor. I could factor a 2 out of the top, but that's not going to cancel anything out, so I'm just going to leave it alone. So in that case, that's just your answer. You can't go any further with that. We don't have a difference of squares here, like 8 and 10 aren't perfect squares. You're not going to break that down. So this would just be your answer. Okay, now this is the one that always trips people up. So my least common multiple here, I have an x plus 9 and an x. The most common mistake I see, people will literally just add a 9 to the top and bottom of that second fraction. You cannot do that. What you have to do to add these together, you have an x plus 9 here and you have an x here. So I need an x plus 9 top and bottom here. And on the first fraction, I need just a plain x top and bottom to create that common denominator. You can't add a 9 to the x. Not allowed to do that. It has to be multiplication, so you have to multiply by that factor. Okay, now to simplify this, the top of this first fraction is just going to be x. Now on the bottom, just go ahead, leave it in factored form. Don't FOIL it out or multiply it out or distributive property. I'm just going to work on the top. So I'm going to take here this second fraction. I would have to distribute the 3 to both of those terms that I needed to get that common denominator. So this would be 3x plus 27. And then that has that same denominator, x times x plus 9. Now, across the top, to actually add these, you can combine something a little bit. This 1x and the 3x will turn that into 4x plus 27, which 4 and 27 don't have anything in common, so that's not going to factor or anything like that. And the denominator is just that x times x plus 9. Nothing's going to cancel there. You can't go any further with that. That would just be your answer. Okay, now, if you have something that's not in factored form, I would tell you, in the denominator specifically, then we would want to factor it. All right, so let me just rewrite this question C here real quick. Now, can you tell me two numbers for the bottom of that second fraction? Multiply to get 2, add to get negative 3. Yes, negative 2, negative 1. Okay, now, you're going to see what, if anything, you're missing. So, in both of these fractions, I already have an x minus 2 in the denominator. So to create a common denominator, this one is missing the x minus 1 that's over here. So all you'd have to do, x minus 1, top and bottom. Then the denominators match. You don't have to write them in a particular order. We don't have to FOIL out the bottom of that. Just leave it in factored form. But the denominators are now the same. Both the same factors, least common multiple, x minus 1, x minus 2. Okay, now to simplify this. Sorry, this is a little bit trickier than a couple of the questions we just did. I am literally just going to operate on the top of this for a second. So the top of this is the top of this fraction. I'm just going to operate on this. You would have to do like a FOIL or box on that x minus 1 times x plus 3. And then from that, I'm just going to put parentheses around this so I don't forget to subtract both parts of this. I have to subtract the 6x minus 7. Okay, so totally up to you. FOIL box, whatever you want to do. I'm just going to do a little FOIL here. You'd have x squared plus 3x minus x and then minus 3. So we'd have x squared plus 2x minus 3. And then I'm just going to make sure, because we're going to subtract that other fraction, that's the numerator of the other fraction, just make sure you distribute that subtraction sign. So it'd be minus 6x, but then it would be minus a negative 7, so it would actually be plus 7. So I'm just going to combine my like terms here. We've got, let's see, x squared, 2x minus 6x minus 4x, and negative 3 plus 7 is 4. Okay, so this is just the numerator. So let me put it back together. So the numerator, actually, give me 1 second. I'm going to put the denominator. That common denominator was x minus 1, x minus 2. Can you guys factor what we got for the numerator at all? Can I think of two numbers that multiply, get me positive 4, add to get me negative 4? 2, they're both 2, yeah. This would be x minus 2, x minus 2. I'm going to write that on top here. And because that factors, actually, when I do that subtraction, one of those sets of factors cancel. So you have an x minus 2 on the top and bottom. So what's left over would be your answer. So just x minus 2 on the top, x minus 1 on the bottom. You could drop the parentheses if you want. I'm just not writing it again. Anybody have a question? Okay, let me do... If you can factor something, do that. So let me slide over to this guy here. 5x and 10 are both divisible by 5, right? So x plus 2. And on the bottom, 12x and 24 are both divisible by 12. Now, this is kind of a tricky question. So I'm going to try and create a common denominator here. I have an x plus 2 in each of them. So what I'm missing, I have a 5 in one and I have a 12 in the other. So to create a common denominator, I'm trying to think of a number that 12 and 5 both go into that's smaller than 60, and I don't think there is one. Okay, so here's what I'm going to do. This one needs a 5. This one needs a 12 to make those denominators match. What I would tell you to do on the bottom, I'm just going to multiply 12 times 5, which is 60. On the top, we're going to actually multiply. So 8 times 12 on the top of this is going to be 96. 12 times 5 is 60. Just leave the bottom of this in factored form. Don't actually distribute that. 6 times 5 is 30 on the other one. But when I multiply top and bottom by 5 there, that creates my common denominator. Okay, now, don't try and simplify at this point. Make sure you do the subtraction first. Like I know 96 over 60 reduces, and I know 30 over 60 reduces. But put it down to one fraction before you try and reduce anything. So 96 minus 30 would give me 66 on the top. You have 60 times x plus 2 as your common denominator. Now, totally, if you can, you're allowed to reduce this, because on the top I just have the one term, and on the bottom I have a product. So can I reduce 66 over 60? What would that reduce to? Heck yeah, 11. Both of those are divisible by 6. So 66 divided by 6 is 11. 60 divided by 6 is 10. Now, the x plus 2 would just stay the same. That would be your answer. Some of these are a little bit, like the one we did right before this was a lot trickier than that. So it kind of depends on the question, what you might have to do to simplify. Okay, and we're going to do one more. I think this one's the hardest that I have on the sheet today. So I'm just going to factor, just like we've been doing the last couple of days, to see what I need for my least common denominator here. All right, x squared minus 9, difference of squares, x minus 3, x plus 3, does not matter which one comes first or second. The second fraction, can we think of two numbers that would multiply to get negative 6 and add to get 1? What do you think? I always think this is tricky when it has this 6. Grace, what do you think? Yes, 3 and 2. Okay, so it's got to be plus 3, so I get the plus 1, and minus 2, so I get the negative 6. Okay, now, just see what you're missing. So both of them already have an x plus 3, right? Both of them already have an x plus 3 here and here. So I don't need to introduce that into either one. This one has an x minus 3, and this one does not. So this guy needs an x minus 3 to make these match. This guy has an x minus 2. This one does not. So I need an x minus 2, top and bottom, to make this match. Now, when you get your common denominator, it doesn't matter the order, excuse me, that you put the factors in. It just matters that you have all three the same, okay? So my denominator there, x minus 3, x plus 3, x minus 2. It's in each of them. What I'm going to do here, let's just operate on the top for a second. We're going to add these together, so I'm just going to work on the numerator at the moment. So I'm going to take just what I have up here, just kind of operate on this, and just remember that's your common denominator there. So I'm going to distribute and distribute here. We're just adding. I'm not distributing a negative or anything. 2x times x is going to give you 2x squared. 2x times negative 2 would be minus 4x. Okay, now we're just adding these fractions that have common denominators, so I'm just going to distribute this like a positive 5. So it'd be plus 5x and then minus 15. All right, so just combine like terms there. I've got 2x squared plus x minus 15, and then I want to see if we can factor this. So I'm just going to go ahead and slide that 2x to the beginning. That first term, just drop the squared, put that at the beginning of both of them. This won't be the answer, but this is the fastest way I've ever learned how to get you there. All right, now you got to multiply first and last. So 2 times negative 15 is negative 30. And you got to add to get the number in the middle, which is 1. can we think of two numbers that you'd multiply them, you'd get negative 30, but when you'd add them, it'd be positive 1? Eli, what do you think? Yes, so one of them will be -5, one of them will be +6. Now, one or both of these is not the real factor. To decide that, just see if they have anything in common. I wrote the 2x minus 5 first, so the second one, those two guys don't have anything in common, but this one, 2x and 6, are both divisible by 2, so that's not the real factor. So the real factor, we're just going to disappear out that 2, just divide both by 2, should be x plus 3. I'm just going to do a quick spot check. 2x times x is 2x squared. -5 times 3 should give me the number on the end, which is -15, so we should be good there. All right, now, 2x minus 5 times x plus 3 was the numerator. The denominator, I'm going to write the common denominator here. So we had x minus 3, x minus 2, and x plus 3. Those don't have to come in a particular order. I wrote them in that particular order so I could cross the x plus 3's off that match, and then I'm just going to kind of circle my answer. So what's left, we're just going to leave it in factored form. You'd have the 2x minus 5 on the top, and then x minus 3, x minus 2 on the bottom. Is anybody having a question? Okay, good. Now,